All right, so I'm going to start with the instruction to find it on YouTube. Go ahead and start up Google Chrome. Google Chrome is my new favorite browser. It used to be Firefox. Firefox is still good, but I think there are certain features in Chrome that I like even better. It's a cleaner look. So what you do is go to YouTube, and then you type in the name of the class, and also the date of that class. So let's say you're talking about the one on Tuesday. Is it the 30th? 30th. Okay, so you say 2011-08 for August, and then it's the 30th, 30, and there it is. So it's very consistent, so that makes it, if you look at the calendar, it makes it very easy to locate a specific lecture.
Thank you.
Sure.
That was on 8/23.
Sorry?
Oh, no.
Yeah, there are other ones too, like from the previous semester, and the previous year, and so on and so
I think
forth.
I was on it.
Oh, really? I'm testing to see when YouTube will complain to me and say, you have been using like hundreds of gigabytes already. Can you please stop? No, I haven't gotten that yet.
They have the space.
How do you get an hour and a half video on that?
I have been a good boy. I have not been uploading any copyright material, and I have been uploading other types of material. And one day, I log into YouTube, and I just got a message. Now you can upload more than 15 minutes. They didn't quite say for how long, but somebody tested it, and it's 3 hours, 59 minutes, and 59 seconds for one single clip.
Wow.
And they have not imposed any total limits yet, on my account of how much stuff I can upload to it. As far as Google is concerned, storage is cheap. What they want is traffic, so they would much rather pay for a few more terabytes and get the traffic that goes along with the terabytes. Yep.
How many gigabytes is a terabyte?
1,000 gigabyte is 1 terabyte.
1024. 1024.
1024 if you use TIB, and 1,000 if you use TB. There's a binary tera, and then there's a decimal tera.
Oh, wow.
Yeah, but approximately that. Yep.
I was just wondering if anybody can be a note taker.
Okay.
I'm gonna need a note taker at some point, so if anybody wants to take notes and make copies of them, the school will pay you, like, I think $15 a unit or something like that. So if you want to do it, come find me after class. That would be good.
Does everybody hear that?
Yes.
If you take good notes, you can work out a deal with, what's your name?
True.
Okay, True, and and he can pay you for your notes. Would the video capture help?
Yeah, I mean it
It
does.
helps a little. Okay.
Yeah. You just mentioned that notes were good on the test was open notes.
Right.
So then it'd be helpful. I actually have
That's
notes.
true. The test of this. This is a good time to talk about the test. The test for this class, when the class size was smaller, like back in 2007, 2006 or so, we used to go to the computer lab and take our tests online using Moodle, and it will still be proctored. I'll be walking around, but it is online. But now, because the class size is so big, we will take up like 2 sections in the lab, and we can no longer do it online. So that means we have to do it on paper, which is not good for me either, because grading stuff on paper is a lot more work than grading it on Moodle. But I have no choice but to do it on paper. Now when we do things on paper, I cannot allow people to use electronic devices. I know many of you have laptop computers, and in my online version of the tests, I do allow people to use online resources. But when we do it on paper, I have to level the playing field so that everybody has to use just paper. You can bring in notes. You can print out stuff that you want to print out. You can bring in textbooks, class notes, homework assignments, sample tests, and so on and so forth, as long as it is written or printed prior to the class, prior to the exam, you can bring it in. Okay? But I would not bring in like too much stuff, because the more stuff you bring in, the more difficult it is to find the one piece of information that you need for the test. Okay, so my advice is to make your own quote-unquote cheat sheet. It's not cheating, because I do allow that, but you want to kind of condense all the material onto just a few pages, so that you can quickly locate all that material when you're taking the test. Okay, so now it's a good time to get started. I just graded the first homework assignment, and there were a few points that I need to make. First of all, it is important to follow the instructions. So let me go back to that homework assignment and read out the instructions, because some people did not follow the instructions exactly. The first part is download this file and edit it. A few people started from scratch. They just type everything from scratch, and I cannot count that as as the homework assignment. So those people are getting 0 out of 5 points. Now remember, the first homework assignment is 5 points. So it's 5 points out of probably around 300 to 400 points for homework assignments alone. The 300 to 400 points of homework assignment make up to 20% of your final grade. So if you look at the percentage of the first homework assignment, it is for the most part insignificant. So I wouldn't be too bothered you're getting a 0, but I'll be more bothered that I did not follow the instructions. Okay, so that make sure you follow the instructions next time. And then the second thing is you are required to use either OpenOffice Calc or LibreOffice Calc to edit the spreadsheet. And I think last time I told people that I can tell whether people are using LibreOffice and OpenOffice or Microsoft Office. And guess what? You guys already know what I'm about to say, right? A few people used Microsoft Office, and I can see that. I can see that they used Microsoft Office to edit the document, and those people do not get any points either, because that's part of the instruction. So you got to follow the instructions exactly to do your homework assignment. So once again, I know it seems harsh that people who did not follow the instructions completely are all getting 0 points, but I would much rather do it to a 5 point out of 300 or 400 homework assignment than to do it later on with the exam itself. Okay, because I do it in the exam, that will be much more devastating. This way, once I talk about it, hopefully people will remember that, and that's the end of it. Just to convince people who are not so happy right now because they think they lost a lot of points, I'm going to bring up a calculator and figure out exactly how many points people possibly may be missing because of this. And I don't have a calculator here. Fine. I don't need a GUI calculator. I can do it with a command line calculator. Okay, so we're talking about 5 points out of possibly 300, and then the 300 points make up 20% of your final grade. So we are talking about 0.00333333 of your final grade. So that's about what? 0.333% of your final grade. So it's not a whole lot of points, but it does make a point. Nobody's getting that.
That was the point.
Yeah, that was the point. The point is, that's not a whole lot of points, but you got to make sure that you use the right tool to work on your homework assignments. Is that okay so far? Does everybody understand what I'm expecting from the first homework assignment? Okay, very good. Now then, we can move on and talk about the answer to the homework assignment that was due about 7 minutes and 30 seconds ago, which is this one. And this is the usual format of the class. What I would do, the first thing in the class is to go over the homework assignment due that day so that you guys know what the answer is supposed to be. Even if I don't grade it in time, then you can at least compare your solution to my solution and at least understand what it is supposed to be. And unlike on Tuesday, when I forgot to pass the row sheet, I'm going to do it now. I'll start with this corner. Make sure you have a chance to sign your name on the row sheet. If your name is not on the row sheet, there's a blank space at the back. So write down your name and then just check it like that. All right. So the first thing you need to do is to save the document first, save link as, and then I will also make a new folder for today. And for some reason, I cannot do it inside the GUI, so I'm going to do it inside here. Today is the 1st of September. Save it as assignment.ods and then open it from LibreOffice. If you try to open it from inside the browser, it will open it in read-only mode. And then you can save it as a file first and then you can change it. I just personally find it more convenient to do it this way. But that part is completely optional. You can do it either way. All right, so this is the source code and this is the trace. Yep.
Can you do it again to make it an exact copy?
Exact copy?
Yeah, like you put it in spreadsheet 2 with making 2 pages.
New window.
New window. New window.
Yeah, window, new.
Okay.
Yep. I also want to point out that everything that I do in the class, including everything that you see on the projector, as well as my voice, they're all recorded. So if you want to revisit something that I talked about in the class, you can go to YouTube, as I showed a little bit early in the class. Just locate a clip. I know most of the time you don't want to re-watch the entire 80 minutes of lecture, so you can pretty much, if you know approximately when I talk about something, you just skip to that part and replay that part, or just use the skip feature of YouTube so that you can quickly locate the part that you need. All right, so this is sheet 2, and I'm about to do the homework assignment. The first thing I need is a line number column. Okay, this is the same stuff that we have done in the class, except we did not have exactly this code when we did it on Tuesday. We need one column for each variable. We have 2 variables in this case. One is x and the other one is y. And now we start with a precondition. The precondition, I did not tell you anything about the precondition, so you can have any value in x or y. But the point is, there has to be a precondition line. Then we start with line 1. At the end of line 1, x is going to have a value of 4. Because of line 1, it is an assignment statement. The right-hand side is 4, the left-hand side is x, and so we use the value of 4 to update the variable x. Y, on the other hand, is not changed, so it retains its unknown value. Now, if you do not enter anything here, just like a blank, I will accept that as a correct answer as well, because on Tuesday, I already used that trick to, so we don't have to type in a lot of stuff. So this is just as good, it implies that the value of y is not changed on line 4. But I'm just going to do it the complete way in this case. This is line 2. Line 2 is an assignment statement. The second homework assignment does not have any conditional statements. They're all assignment statements. 2 plus x. Okay, the value of x is 4 at this point. So line 2 is really evaluating 2 plus 4 on the right-hand side. 2 plus 4 is 6. And then what do we do with 6?
Y.
We update y. On line 2, x retains its value of 4, but y gets updated to a value of 6. What are we doing on line 3? Line 3 looks confusing at first, okay, because we have x on the right-hand side as well as the left-hand side. But once you understand it's a 2-step process, it should not be confusing anymore. Because the first step is we evaluate the right-hand side. The right-hand side is x plus 1, and x has a value of 4 at this point, so it becomes 4 plus 1, which is 5. And then we use the value of the right-hand side to update the left-hand side. So now the left-hand side, which is also x, is getting updated to a value of 5. So that's why we have a 5 here. And nothing is happening to y, so y retains its value of 6 from the previous line. Line 4 does not do anything to x because y is on the left-hand side and not x. So x gets to retain its old value of 5. The right-hand side is, y is updated because it's on the left-hand side of the assignment statement. the right-hand side is y divided by 2. 6 divided by 2 is 3, and therefore y gets a new value of 3. And then we move on to line 5. Line 5 does change x. We have to evaluate the right-hand side first. Y has a value of 3 at this point. 3 times 2 is 6. We use 6 to update x, so x now has a new value of 6. And y does not have any updates, so it has an old value of 3. And this is all done, but you have to remember to indicate this is the end of the trace using a simple word of post for post condition. That's it. This is the answer to the second homework assignment. Are there any questions about the answer to the second homework assignment?
If you were to be changing both variables, how would you separate the statement? Like if on line 4 you were changing x and you were changing y.
We do not, well, in this form of pseudocode, we do not have the ability to change multiple variables with one single assignment statement. So you don't have to worry about that. That is possible when you're programming in C and some other programming languages. You can actually have a chained assignment statement where you can change multiple variables at once, but not in this particular simple pseudocode. Okay. Any other questions about this homework assignment? Yes?
It's kind of a, what if you accidentally open up the file with Symfony or something? Does it permanently ruin? You got to download a whole new file and then open it with Office?
If you save it, yes.
LibreOffice?
Yeah, if you save it, then it will leave its footprint, fingerprint behind. But if you don't save it, you can just close Symfony and then open it in OpenOffice. Okay. Did you accidentally open it with something else?
Yeah, I just downloaded it again, I think.
Yeah, if you download again, that's that for sure will fix that problem.
All right.
And the assignment that we have right now, they are simple enough. If you have to redo it, it's not a big deal. Okay. Any other questions about the second homework assignment? No questions? Okay. Very good.
I got a question.
Yes.
How much do you take off of those? You entered y squared rather than 1 times 2.
Oh, you mean this part here?
Yeah.
Probably not a whole lot. I mean,
Okay.
Because I can see how someone might think that this is, to the power of, because the asterisk is a little bit higher, but not a whole lot of points.
Okay.
Any other questions? No other questions? Yep.
This assignment worth 5 points too?
I think this one is a 10-point homework assignment. So it's the
0.66.
Yeah, 0.66% of the final grade, assuming that we have 300 points for all homework assignments.
It's like 1% so far.
Yep, 1% so far. Yep, it's all starting to accumulate. Now, the homework assignments, the complexity of the homework assignment as well as the point values, they will increase as we introduce more and more complicated topics. So keep that in mind. So you can afford to lose an entire homework assignment early on and not really have any impact to your final grade. But as we go on, we'll have homework assignments that are worth like 50 points, even 100 points later on. Okay, so it's much better to learn, okay, I guess we're not supposed to do it this way earlier because the price that you have to pay is actually not that much. Okay, so let's close this and get back to where we left off last time. And I can check where we left off last time just by looking at this. I gave you guys a brain teaser and say if you can only use AND, which is a logical operator, and not as a logical operator, how do you express the same thing as X or Y? That was the brain teaser from Tuesday. And I got a few people who turned in their answers. Some are correct, some are close, some are incorrect. But that's okay. It's just a brain teaser. You don't have to get this right. It's not worth any point values. Okay. So if you think about X or Y, did I talk about De Morgan's law in this class? I kind of mentioned that, but I guess I did not, fully explain that. No, I did not. Okay. So let's go ahead and take a look at De Morgan's law. Okay. And you guys tell me whether it makes sense or not. De Morgan's law says something like this. If it is not X or Y, this is the same thing as saying not x and not y. I'm using extra parentheses just to make sure that we know the order of operation. Does that make any sense? Okay, seems to make sense, right? How is this going to be useful to answer our question? Well, it's not the solution, okay? You need one more step to get to the solution. But it's close, because this is the negation of the disjunction of x and y, right? How do I make the negation of the disjunction into just the disjunction itself? Double negation. So I just need to put a not on this side, but since this is an equation, I have to put a not on the other side as well. That's the answer. Okay, let me explain that. Okay, so the first thing is you have to accept this. Okay, you have to take this and say, okay, that seems to make sense. Are there any questions about this part, whether it makes sense or not? No? Okay. So now, if that makes sense, what happens when I take a negation of this side? But then if I do that to one side, I have to do it to the other side, just like with regular algebra.
Yeah, negatives make it positive.
Yep. And they still have to be the same. But in the class, I also explained the negation of a negation, they cancel out. Okay? Not true is false, not false is true. So not true is true itself. Not false is false itself. So that means whatever x or y is, I don't even care whether it is true or not, is the same as the other side. This is why I like to use an editor instead of the whiteboard, because I cannot copy and paste on the whiteboard. I can do it here. It also explains why sometimes it does not make a whole lot of sense for you guys to take notes. It's good that you're taking notes, but it's much better if you pay attention to what I'm talking about. Some people can do both at the same time, which is fine, but if you cannot do both at the same time, I would much rather you to pay attention to what I'm doing on the projector than you're busy taking notes. Yep?
Just, to me, it looks like that's saying x or y equals x and y.
It is not, because you can see that the parentheses indicate when you're taking the not. So this is the part where it's hard to use a editor to do it, but I will try my best. Okay, so if you want to look at the right hand side of this equation, we have an and. Okay, what is the? Okay, I got it wrong. The topmost operation is the not, right? Because the not is outside of the big mess of parentheses. So that's the last thing that we want to do. What is the next item that we want to do? I'm doing it. And, okay. See, I can make a picture out of text. Okay, what is the and doing? What is it ending? What are the two components it's ending? On one side is a not x, right? So we have a not here. On the other side is also have a not y. So the x is here, and then the y is here. And to make this more like a real picture, I can use the slash symbol. And then of course, the other side we use the backslash symbol. I'm wasting time. There's a bunch of little. Yeah. There we go. So that's the structure of the expression. Now this structure is also helpful, because what it means is, if all that you have is an AND gate when you're implementing the logic of a computer and a NOT gate, this is how the signals are connected. The inputs are X and Y, they go through a NOT gate, and then the output of the NOT gate goes through an AND gate. The output of the AND gate has to go through another NOT gate before it becomes the disjunction. Okay, I'm not going to draw these gates using just ASCII code, because that's just a big waste of time. This is a little bit of waste of time. That's more waste of time. Yep.
So do we need to look at that diagram and go from the bottom up? Because if you're going from inputs, right?
Correct.
If I'm inputting X, then okay, X, not, and not. It's
Right.
It doesn't go from the top down.
When you evaluate, you have to start from the bottom.
Okay.
Yep. Because the picture displays the hierarchy of the operators. The top one is the last one to apply.
Okay. I guess what's throwing me off a little bit is on the right-hand side of that equation. I'm looking at it like a math equation. You have not on the outside of your gaggle parentheses there.
Right.
So that not would be distributed, correct? It
The
would
not
the
is
not
up.
would go to not X and not Y.
You mean this knot here?
Yes, sir.
This
Okay.
knot applies to the entire mess here.
Right.
So it applies to the result of the conjunction.
Okay.
Because when you look at the inside, which is this part here,
Mhm.
the conjunction is the second last operation to perform. So before the conjunction, you have to first evaluate the negation of X and also the negation of Y. Okay. All right. So that's the answer to the brain teaser. But somebody's going to say, I'm not convinced that that big mess on the right-hand side is the same thing as X or Y. So I'm going to show you a technique to prove that they are in fact the same.
Truth table.
Truth table, exactly. With binary or Boolean logic, we can use truth table. What is Boolean? B-O-O-L-E-A-N. True, false. Okay, anything that has to do with just true, false value is called Boolean. And why do we call it Boolean? Why is it bool? B-O-O-L-E. Exactly. That's the name of the mathematician who came up with Boolean algebra. Because you already know regular algebra, right? X plus y equals y plus x. X plus y plus z equals x plus y first plus z. The same kind of thing can also work with Boolean logic. Boolean operators have their own set of rules. And a lot of times they look exactly like the rules that you have already learned with regular algebra. But we're not going to talk about that just yet. What I'll do here is to prove that the x or y is really the same as this mess here. Okay, we know that x can be true, it can be false, right? Because it is a Boolean value. It is a true, false value. Y is the same thing, but when x is true, y can be true or false. When x is false, y can be true or false. Is that correct? Okay. Am I missing any case here? Is there a fifth case that I'm missing? Nope. This spells out all the possible combination that can serve as the input to the big, huge expression, on the other side here. Now we already know the definition of OR, right? If at least one side is true, the whole thing is true. So that means, in this case, what is the result of x or y? True. But in this case, true, true, true. And this is the only case where it is false because both sides of the disjunction are false. Okay. So now we need to look at this big mess here and try to figure that out. When x is true, not x is false. When y is true, not y is false. False and false is false. Not false is true. What if x is true and y is false? Not true is false. Not false is true. So this entire thing becomes false and true, which is false. Not false is true. And it's somewhat symmetric in this case. In this case, x is false, y is true. Not false is true, not true is false. This is true, and this is false. True and false is false. Not false is true. And then we have the last case. The last case is saying we have not false, which is true. We have not false, which is true. We have true and true for the conjunction, and that is true. No, true and true is true.
Oh,
But since the conjunction is inside the negation, we have to take a negation of true. What is the negation of true?
False.
It's false. Okay. So for every single possible input, these four, the two expressions end up with exactly the same result. So that proves that the first expression, which is what we normally use as human beings, and the second expression, which is kind of long and complicated, but that's sometimes what you have to do because of the type of gate that you can have inside the computer, they are equivalent. They are exactly the same. They will do exactly the same. If you give them the same input, they will give you the same output. Now this is really cool because you cannot do this kind of trick with regular algebra. Because without regular algebra, you're dealing with integers, and there's an infinite number of integers. And you cannot just enumerate all the possible cases. With Boolean logic, you can enumerate all the possible cases. If two expressions evaluate to exactly the same result for all the possible inputs, they are equivalent. They are the same. Okay. So this is not something that I would test you in an exam, but I think it is useful to understand, especially if you're moving into computer engineering and also electrical engineering. It is also useful in programming, because if you see someone writing this kind of code, you will know that, oh, that simply means X or Y. So you can simplify the appearance of a program just by understanding that the right-hand side, which is a big mess, is the same as the left-hand side, which is a whole lot easier to understand. Any questions about this part? Yep.
How come on the or side you have true and false and that equals true, but on like the and side you have true and false and that equals false?
Because true and because there's a negation to X first. Are you talking about the first row? This case here?
Like on like the true and false or true X.
You mean this one?
Yeah.
Okay, in this case, what we have is X is true to begin with, but then not X is going to be false, right? We have Y being false, not Y is going to be true. But if you look at the entire conjunction, we have false and true, which is false. The conjunction gives you a false. But if the conjunction gives you a false, the negation is on the outside, not false is true. I know it's kind of cumbersome because of all the parentheses. You just have to kind of feed the values to the picture and evaluate each way along the way, and then come to the top here and come to the final answer. Yep.
I was just going to say, I think he was, you may have answered his question, but I was thinking the same question of why. It's because you got or on one side and on the other, where and is if it's true and false. Then
Exactly.
It's false. But if it's or, then it's if it's true or false.
Correct.
I think that's, I had the same question.
The magic is coming from the negations. Because of the way I arranged the negations, I can turn a conjunction into a disjunction by properly placing the negations. Any other questions? If you like this kind of stuff, you want to get into computer engineering or electrical engineering, because that's basically what you do all day long when you design digital devices. How many people enjoy this? Yep, go ahead.
How many people got it right?
I don't know. This is not an assignment. I'm just I'm just telling people to try to think about it. One person sent me an email and it was completely correct. Yep.
Would the true and falses have a correspondence with zeros and ones?
Yes. Inside the computer, true is usually represented by 1 and false is usually represented by 0. And when you represent true as 1, false as 0, then we have other tricks that we can do, because or becomes addition. Kind of like addition, not entirely. And then and becomes kind of like multiplication. So there's not a 1-to-1 correspondence, but most of the time, you can equate true to be 1 and false to be 0. Any other questions about this example or brain teaser? No questions about the brain teaser? All right, look there. Yep, go ahead.
So the negation of the right side twice more would equal the same thing.
The negation of the put another knot here.
Put another knots.
You mean if you put another knot here?
Another knot.
Then you have to put another knot on the other side too.
And then you add another knot, so it would redundant knots.
Correct. Yeah, but at this point here, we do not have a single redundant knot. And I have to count the parentheses to make sure it's still right. One too many. There we go. Yep.
The same thing also could able to be done, like scroll up a little bit.
Okay.
Further. Okay, you have and not, and you use it to represent X or Y, would the same thing also hold true, almost the same, as if you use or and not to represent X and Y?
Yes. You mean this one here? You mean why these two are the same? That's the first example of using De Morgan's law. Remember, I'm not going to quiz you guys on De Morgan's law or how to transform all these things. These are all pretty much extra stuff for people who are interested. But I think that programmers should be exposed to this sort of topic. If you don't get it the first time, it's no big deal. But you should understand that if you write programs, this stuff should not bother you. Okay. Any questions? No questions? If there are no questions, we'll move on and continue to talk about conditional statements. So we are. It's a new tab. And another new tab. There we go. So we were talking about conjunctions and disjunction and negation. And now we go back to the example. The example or the solution to finding the maximum of 3 variables, one solution is like this. Okay? So if you look at this solution, it simply says if W is greater than or equal to X, and remember the little TP symbol represents and in mathematics, and W is greater than or equal to Y, that means W is the maximum, and we'll use W to update Z. Does that make any sense? Okay. Now, this is something that we have not seen before. What is else if? Well, in a normal case or in normal English, that means if the first case works, I'm not even bothered. I won't even bother with the second case. On the other hand, if I can confirm that W is not the maximum, then I'll go ahead and take a look at the second condition and see if X is the maximum. So I evaluate this condition only if the first one is not true. Okay, so let's take a look at the second condition. X is greater than or equal to W, and X is greater than or equal to Y. That confirms that X is the maximum of the 3. If this condition is true, we know X is the maximum. If that is the case, we can update Z using the value of X. And then we have another else here, which is saying, well, if this condition is false, and this condition is also false, then we'll go ahead and do this part here, because in that case, we have just confirmed that X is not the maximum, W is not the maximum. Since we only have 3 variables, Y has to be the maximum. Okay, so that's the logic of this kind of more complicated form of a conditional statement. I call this a multi-branch conditional statement because instead of just giving you 2 ways to branch out, it gives you more than 2. That's why it's just called multi-branch. Okay. But the question now is, what does it look like? If I want to draw a picture to represent this logic, what does it represent? I mean, how do we draw that? The picture is more like this. Okay. So let me overlap the text window here, and I'll just explain what this means. This is corresponding to a multi-branch conditional statement that says if condition 1, then this block of code here, block 1, I'll just call it block 1, else if condition 2, then block 2, I'll call this block 2, else block 3, and if. In other words, this chunk of code in pseudocode matches this picture on the left-hand side. Yep.
You need the second for the second.
The second,
Because you have 2 if statements.
This is considered one single conditional statement.
But you have a conditional statement nested inside a conditional statement.
It's not exactly nesting. You can do it using a nested conditional statement, but in this case, it's a single conditional statement. You just have multiple branches. It depends on the programming language. Some programming languages support, else if, else if, else if, including Visual Basic. Other languages like C and C++ does not support the basic concept of a multi-branch conditional statement. Are there any questions about the equivalency of the picture on the left-hand side and the text that is on the right-hand side? No questions about that? So the structure of a multi-branch conditional statement is okay with you guys?
Can we see that?
Hmm?
Can we see that?
See?
Can you see, you can show an example?
Sure. Okay, so let's go ahead and trace it. Okay, because the best way to make sure that you understand, or at least I understand the concept, is to trace these particular code. And we'll go ahead and trace it using OpenOffice Calc again. And I'll do exactly the same thing that we did a little bit earlier. So if W is greater than or equal to X, and W is greater than or equal to Y, then Z gets W. Else if X is greater than or equal to W, and X is greater than or equal to Y, then Z gets, what is it? X. Else Z gets Y, and if and I would also use indentation to indicate which code is contained within which other code. So increase indent like that. Okay. This is my program. What I'll do is I'll use sheet 2 and sheet 3 as test cases to see if this code actually works correctly or not. Well, if we're going to check whether the code works correctly or not, let's go ahead and introduce some bugs into this program. Okay? Yep, go ahead.
Okay, so in an actual computer program, those are the lines,
Yeah.
and so a line would
This would be very similar to what you have to do in Visual Basic, except in Visual Basic, I think, do they spell else if as one single word? Yep, yep. So minor syntactical changes.
What I mean, so like a comparational, that's a line executed in a computer to compare it if W is greater than or equal to two things. That's the actual executable line command.
This is very close to the Visual Basic representation of the same logic. Yep. Only with the minor difference of else if is spelled as one word instead of two in Visual Basic. Okay, so let me just throw in a bug so that I can show you that you can test, you can confirm the existence of a bug by test cases. It doesn't seem to be that big of a change, does it? I mean, I just changed greater than or equal to just greater than. Okay, in terms of concept, it seems like it should still work, but I can show you that there are cases where this will not work. But there are only very few cases by comparison that this does not work. It does work in general in most cases, but there are cases where this will not work. So this would be our little challenge here. And I will save the file first before I forget. And I'll say this is bad max 3 because it does not work. It has a bug, it has a defect in it. Okay, so now we'll use our second tab, or sheet 1, to trace the algorithm. In this case, we need comments because we have conditional statements and we have conditions to evaluate, so we need comments so that we can indicate the result of the comparison. We have 4 variables in this case, but for the most part, we are only interested in Z, because W, X, and Y do not have their values changed, but I should represent them as well. So we have W, oh, I forgot one thing, my number, and we have W, X, Y, and Z. Let me just, Let me shrink the columns first so it will fit nicely on one single screen. This one can shrink a little bit. This one needs to be a little bit longer. That. All right. Okay, so now we can see both the source code and also the trace at the same time. Now with this one, I have to give you some sort of precondition. Otherwise, there's no way you can compare an unknown value to an unknown value. So that means I have to give you specific values for w, x, and y in order to proceed with this algorithm. Let's try something that works okay. So we have 1, 2, and 3. Easy. On line 1, it is a conditional statement. We are not changing any of the variables. But instead of changing anything, I have to reflect the truth or false value, true or false value of the condition. If these are the values of w, x, and y, what is the result of the comparison? W is greater than x is false, and w is greater than y is false, and false is okay. So we just say the entire expression evaluates to false. If that is false, where are we going to go next? We go to line 3. Okay. Now, how do we know that we have to go to line 3 instead of line 6 or whatever line? Well, you have to look at this picture, because what we have just done is condition 1 is false. When condition 1 is false, we take this false branch here, and then we have to evaluate condition 2. In our spreadsheet, condition 2 is this condition on line 3. So that's why the next line we have to execute is line 3. Line 3 is asking, is x greater than w? That is true. How about x is greater than y? That is false. True and false is false. So the entire thing is false. Fine. Where are we going to go next? We go to line 6. Very good. You guys are very good remembering that I do not track the line. We don't track line 5 because else doesn't do anything. It is a separator to separate what we are supposed to do when this condition is true and what we are supposed to do when both of these conditions are false. In other words, line 6 corresponds to this little block of code here, because both conditions evaluate to false in that case. Okay. Line 6 is not very puzzling. It's a simple assignment statement. We take the value of y, which currently is 3, and then we use that to update the value of z. And I forget one thing. I forgot to declare that we did not know the value of z to begin with, but now we do, because we just copy the value of y to z, and after that we get out of the conditional statement, and it is done. Not a problem. Okay. Remember what I said a little bit earlier? There's a reason why the file is called bad max3, because it doesn't work in some test cases. Does someone want to give me the test case, where this code does not work? Okay, hold on. Let me make sure that we can see all the columns first, and then I'll let you guys tell me what your answer is. Okay, so how do you want to change this so that that program does not work anymore?
3, 2, 1.
3, 2, 1? 3, 2, 1 will work.
Change x to 1.
Change x to 1.
Yeah. Or just make
1, 1, 3? 1, 1, 3 will work.
What about all?
Make it all the same.
How about 3, 3, 2? We have two values of the same value, and they're both the maximum. Okay, so we'll try 3, 3, 2. 3, 3, 2. Now, just by looking at the source code, can you tell that it won't work in this test case? Pretty hard. I mean, I would not be able to tell that it does not work if I have not been using this example for the past, 10 semesters or so. I would not be able to tell either. So that's why tracing is useful, because it allows you to track down the algorithm step by step and see whether it works or not. Okay. So let's go ahead and get started. Line 1. Okay. What is the result of line 1 after this conditional statement?
False.
Okay, so we'll do it step by step, okay, because we have w. W is greater than x is, it's false because 3 is not greater than 3. So that's false already. what is W is greater than Y? No, that's true. But since we have the first one being false, the entire thing is false because you only need one side to be false for a conjunction to be false. Okay. All right. So where do we go next? To the line 3, just like last time. Line 3 evaluates another condition. X is greater than W is
False.
false. X is greater than Y is
True.
true. False and true is false. So where do we go next? To the line 6. So according to the logic, we go to line 6. Line 6 says, well, just copy the value of Y to Z. Y has a value of 2, so we're going to make Z exactly the same. Right, just a little bit more, and that's our conclusion. In other words, according to this program, the maximum of 3, 3, and 2 is 2. That is incorrect. Okay? And that's only because I made all the greater than or equal to just greater than. Okay? Now, how many of you think that you will remember to test, this particular test case instead of test cases that have all 3 different numbers? Because the bug is not going to show up as long as all 3 numbers are different. It will only show up when the maximum is the same. Let me rephrase that. It will only show up when 2 variables have the same value and they are both the maximum. Okay? So this is a big problem. To me, this is a big problem because how can I make sure that my test cases are enough to confirm that the code will work in all cases? I can give it 50,000 test cases, and yet the 50,001 test case may fail. But in this case, you can look at the source code and say, well, I can kind of see why equal to is important, so we should test it with 2 variables having the same value. But what if this is a 50,000 line program instead of a 7-line program? It gets a little bit more complicated, doesn't it? So that's why program verification is very, very difficult to do. It's really, really hard to make sure a program will work 100% all the time. So keep that in mind, before when we talk about the program verification later or the pre and post condition stuff. This is why we have to deal with the pre and post condition stuff. On the other hand, are there any questions about how we trace this code? The behavior of a multi-branch conditional statement. Any questions about that? Yep.
So the multi-branch will always have the comments, right?
Always have a...
The comment section?
Yes, any program that has conditions to evaluate needs to have a comment so that you can tell me why you go to line 3 from line 1 and why you go to line 6 from line 3. Why you make the decisions the way you did. Is that okay so far? Before we move on to some trickier multi-branch conditional statements.
The comment section, do you want it to be written exactly that same way, or did we modify it to make it a little clearer for ourselves?
You can make it more clear for yourself, but this is the bare minimum that I'm expecting. Okay. Any other questions about the 2 test cases? No questions? Okay. So let me close the spreadsheet first and save it first. So now we'll move on to something that's also a multi-branch conditional statement. But this one is a little bit more confusing unless you already understand the exact behavior of a multi-branch conditional statement. All right, so let me write the code first. The code will be kind of simple. So I would say if x is less than or 10, we do one thing. We just say y will get a value of 0 in this case. Else if x is greater than 100, then y gets another value. Let's say it gets a value of 1. Else if x is x equals, I don't know, 15, then y gets a value of 2. Else if x is -5, then y gets a value of 3, else if x is greater than -10, then y gets a value of 4, else y gets a value of 5. And if 2, 3, 4, 5, 6, increase the indentation. It looks like it's just tedious, but it's not. This is actually a little bit tricky. Yep.
Isn't there already a bug in it? Because there's
Well-
going to be 2 y's.
Well, if I did not tell you the proper behavior of this program, there's no bug because you cannot say it is not what you think the program should do. So what we want to do is to see we want to understand the behavior of this algorithm. What you're thinking is, hey, something is not going to get the value. I mean, certain lines is useless. Is that what you're thinking?
Well,
It's not a defect. A defect can only exist when you have, on one hand, you have the expected behavior of the program, and the actual behavior of the program is not the same as what you expect. But since I did not tell you what the program is supposed to do, you cannot say that it is defective. What you are saying is something is fishy, right? And it is. Yep. It is fishy. Yes.
How do you do the shortcut to number the?
Oh, okay. The shortcut to do it is, okay, let me do it again. You just click on one cell, and do you see this little block here?
Yeah.
You move your mouse pointer over that until it becomes a cross, and you just drag it down.
Oh, okay.
It's called autofill. It's a really useful feature in the spreadsheet. This is just a very simple way of using autofill. Autofill can be far more useful than this. Once you have equations and formulas inside the spreadsheet, it becomes even more useful. Question?
Can you show us the indentation again?
The indentation? Absolutely. Why don't I just redo the whole thing? Undo. Undo. Oh, no, undo. Undo. Control Z, Control Z, Control Z, Control Z, Control Z, Control Z. Okay, let's start from here. I know this is not a spreadsheet class, but if you want to really know how to use a spreadsheet, you should take CIS A315, I think. It's a 2-unit class, and you can learn everything, well, not everything. You can learn about 4 things you can do with a spreadsheet in that class.
4 things?
Yes. Of which, most other students in that class will retain 3. Okay, so the first thing is you want to be able to control click. Control click allows you to select blocks or cells that are not contiguous. Shift click will select blocks that are contiguous. Now this is a trick you can do in Windows as well. When you want to select only certain files to delete, you can control click only on the files and folders that you want to delete and then press the delete key. So once you have selected these cells, you can select the tool which is increase indent. Okay? And that will change the indentation here. Now for the line numbers, I start the first line off with 1. You can start with something else as long as the line numbers are sequential and unique. It's fine. You can start with line 100 if you want to. But I just start with line 1, and then you move your mouse pointer until it becomes this little icon, and then you just drag it down, and you're done. Yep.
The reason your whole program won't work is because you're testing equalities after
Exactly. So to change the width so that it is exactly what each column needs, you select the columns. Don't select the cells. Select the entire column, and then I'm using shift click here to select the other column, and then you go to the border between 2 columns, and then double click when the icon is a double-sided arrow, and that will automatically resize the columns or change the width of the columns to just fit the content of those columns. Okay. For the most part, you guys don't have to deal with this a whole lot. But it is handy to know how to do this.
One other quick question. Auto sum on that if I was doing something else?
Auto sum?
Yeah. If I was just doing something.
You can use equations and formulas, but we are not going to do a lot of that. Okay, so now we want to trace this algorithm. Do you guys want to start with the tricky ones? Because the non-tricky ones are going to be just a little bit boring. Let's try one that is boring first, okay? Just kind of build up the atmosphere, right? Okay, so we have comments because we have conditions to evaluate. We have line number so that we can keep track of which line did what. And then we have only two variables. We have x and y as the only two variables in this program. And out of x and y, x has to have a known value to begin with. So the precondition is I have to give x a particular value. And in this case, I can give it something that is easy first. Let's try 9. Okay, so I'll say that x starts with a value of 9, y starts with a value that is unknown. And what is the result of line 1? What does line 1 do? Line 1 evaluates a condition, and then we have to decide where to go next. It can either go to line 2 or line 3, depending on whether x is less than 10 is true or not. X is less than 10 is true. Okay, that makes it easy. Where do we go next?
2.
We just go to line 2, right? Because if the condition of a conditional statement is true, you just go to the then corresponding to that particular condition. So we go to line 2. Line 2 is a conditional statement, is an assignment statement. We are going to change the value of y to 0. Y gets a value of 0, and then what do? Post. We go all the way out. And that's because when you look at this picture, as soon as you get through one of the blocks, you go all the way to the end. Is that part okay? Now that is important because you will see that in some other test cases of this program, not getting out right away will cause you problems. Yep.
You haven't defined what the expectation of the pseudocode is supposed to do.
That is correct.
Okay, so right now we're just assuming that it's written correctly.
We are just pretending to be computers executing the program.
Okay.
So we are blindly but faithfully following the logic. And that's basically what you'll be doing for this entire class, this entire semester. Because I'm not interested in designing the program at this point or to solve a problem. I want you guys to understand, if you write a program like this, what is the computer going to do? Okay, that's the focus. We have to understand the words, the vocab, and the syntax of the grammar first before we start to do creative writing. Okay, so that's the easy one. Oh, but some people may have questions already and say, but if x is 9, doesn't that also match some of these cases? Isn't 9 also greater than -10? Yes, it is. But we never got a chance to evaluate this condition. Because according to the picture, okay, always go back to the picture. If you take one true branch to execute the code, you get out right away. You don't have a chance to evaluate another condition because of that. Is that part clear? Okay. Yes. I thought I saw a hand. Okay. All right. So given that, let's take a look at another test case. So we'll go ahead and let me see if I can paste the format as well. So we'll paste all, and it already has everything included, so I can't paste the format. Yeah, that's fine.
I think if you right-click and paste, it does it different than Control-V.
Sorry?
I think if you right-click and paste, it's different than hitting Control-V.
Okay, we'll try that with the next test case because we'll have more test cases after this. Okay, so let's try another test case here. Let me ask you this question then. How many people think that there will be a way to get to this part here? Get to line 10. Give me a value of x so I can end up on line 10 or line 12. Or for that matter, line 8.
14.
14? Okay, let's try 14 and see what happens. Okay, so let's try 14. Now, if x is 14, then line 1 is going to evaluate the condition. X is less than 10 is what? False. False. Very good. And if that is false, where do we go? We go to the next condition, right? We try to evaluate the next condition, which is on line 3. Line 3 is trying to see if x is greater than 100. Is that true or is that false?
False.
That's false as well. So where do we go?
5.
We go to line 5. Line 5 says, does x equal to 15? False. Then we go to the next one. We go to line 7. And what is that?
False.
Okay, x equals to -5 is false. And then we go to line 9. X is greater than -10 is finally true. So we can go to line 10. Y gets a value of 4, and we're done. Well done. What about x equals to -5? Can I get to line 8?
Yeah.
How do we get to line 8? What does x have to be to get to line 8? It's impossible. Now, why is that impossible? I mean, it clearly states here that when x equals to -5, we put a value of 3 into y. So that makes it a very easy case, because what if we just make x equals to -5 to begin with? Then it's going to match the first condition. Y gets a value of 0, and we are out. Right? What about this condition here? Y gets a value of 5. Can we ever get there?
No.
Why not?
It's less than 10.
Because those conditions cover everything already. There's nothing else to correspond to this case. In other words, in order for me to get to line 12, you have to give me an x so that x is not less than 10. X is not greater than 100. X does not equal to 15. X does not equal to -5. And x has to be less than or equal to -10. Such a value does not exist. And as a result, this is a dead branch. Yep.
But what if you make a condition after that condition? To
Which
switch
one?
the
After
number,
which line?
to get to the bottom, or to
Right.
get to like 8, you said if you can't get to it, but right before you get to it, you switch that condition.
Ah, very good. That's good observation. What he said is, what if we take this block of code and change the order and move it somewhere else? That will fix the problem. Well, you have to move it all the way to the beginning, because -5 is, when x equals to -5, it is automatically less than 10. So you have to exchange this with the very first condition to make y, to make it possible for y to get a value of 3. Okay, that's very good. So that tells you something that is important, because the order of these conditions is important. If you ask these questions in a different way, the behavior of this program will change, but not in a major way. It can be very subtly. Now, in this program, most people can look at this program and just imagine a number line, and then quickly figure out which cases are not possible. But what if these conditions are not simple comparisons? What if it is this is a part of TurboTax to evaluate which rule applies to your tax return? How complicated are those conditions? Well, enough to support an entire industry, right? It is complicated enough to support an entire industry to help people do their tax returns. Now, in those cases, how can you be sure that the order of the evaluation of the conditions is correct? And that's why you have patches from TurboTax. Oops, we made a mistake here. Okay, push out another patch. Okay, so when you write programs, you have to be careful, because it is very easy to specify the conditions in the wrong order, and then your program behaves incorrectly. But not in all cases. It will only behave incorrectly in some cases. And those are the most difficult bugs to diagnose. Is that most of the time it works, only sometimes it does not work. Yep.
Has there ever been the perfect code program that's never had something very complex? It's never. What's the most perfect, most complex?
What is the most perfect and complex program?
Yeah, that's ever been.
That I do not know. Because TurboTax is not exactly an algorithm. It's not, to computer scientists, TurboTax is not interesting at all. Because what it is it has a lot of mundane details. It has details upon details upon details, and the correct implementation of TurboTax depends on the tax code. Okay, when you read the tax code or any legal document, they will have everything listed, and they will tell you that you have to first check this condition. If it does not apply, then you check the next condition. If that does not apply, you check the next condition. So the order of evaluation is actually built in to the tax code already. So the TurboTax programmers just have to observe that and make sure they implement the program, respecting the same order of evaluation. But for us, we can, write, multi-branch conditional statements. Sometimes with business applications, there's a lot of this stuff too. And you have to make sure that the conditions are all evaluated in the proper order. Or in some cases, if whoever tells you to write a program did not tell you the proper order of or the precedence of these conditions, you should ask. Okay? Because if two conditions overlap, you can potentially have problems like this. You can tell that these are overlapping because this condition overlaps with this one as well as this one. Because I can find values that are less than 10 and also greater than -10. And whenever you have overlapping conditions, you have to be careful because which way it goes or the ordering of these conditions become important and significant. Any questions about multi-branch conditional statements before we continue? No questions? Perfect. So we can have our next homework assignment on conditional statements. I'm not going to give you the assignment statements. The assignment right now. I will go back to my office and post the assignment after this class. Okay. So make sure you check that. Make sure you check Moodle and do the homework assignment. We are meeting on next Tuesday. Okay. There's no class on Monday, but this is not a Monday class, so we will meet on Tuesday. We're not done yet. We still have 10 more minutes. And now we can move on to something more interesting. So let me save this file first. Okay, so I'll call this multi-branch. Okay, then can anyone tell me what the next topic is going to be?
Loops.
Loops, exactly. Loop is also interesting. Tell me what kind of program can we write at this point with all the statements, all the different types of statements that we have talked about so far. We have assignment statements, right? We understand most of the operators, multiplication, division, addition, subtraction, parentheses, and stuff like that. We know how to do computation. We have conditional statements. We even know multi-branch conditional statements. We can make decisions. If this is true, we want to do this. Else, if this is true, we want to do this, and so on and so forth. Can I do something again and again?
Yes.
No. No, because if you look at the structure of the code we have so far, it goes only one way. It only goes down. Even the conditional statement is going down. It only gives you the ability to go either way. But in the end, it's all going down and merge at the very end. In other words, we are looking at a waterfall at this point. You look at water going through a waterfall, it will branch out, but eventually they will all merge when they all get collected at the bottom of the waterfall. We don't have a cycle yet. There's no way for us to pump water back to the beginning of the waterfall at this point. Now, why is that important? What kind of daily activity that you do on a daily basis that involves repetition?
Walking.
Sorry?
Come to college, go back home.
Okay. What about finding a parking space? Is that a repetitive logic or is it a one-shot logic? It's repetitive, right? Okay. You keep driving around and around and around and around, and the size of the loop depends on the person. Okay. Some people, just cannot stand to have to walk a little bit further, so they only make little circles, really close to the campus. Other people feel, well, I'm going to save my time. I will go to the furthest spot because it's most likely to find an empty spot. I'll just park and walk. That way, it is predictable. I know how long it will take me to walk, to campus from that really far spot on the parking lot, but then it is predictable. I can just prepare for that. So it is still a loop, though. Okay, it's still repetitive. What happens when you do dishes? When you wash, your dishes? Is that a repetitive process?
Yeah.
It's a repetitive process. Okay, so most of the things that we do on a daily basis are repetitive. If someone tells you to do something, what are some of the key words in English that will give you the hint that this is a repetitive process?
Do this until.
Until, okay, repeat, as long as,
While.
okay, while. So those are all clues that you're dealing with something that is repetitive. And repetitive or repetition is important in programming because a lot of times we need to do things over and over and over again. So a loop is a control structure. A conditional statement is a control structure. A loop is also a control structure because it changes the flow of the execution of the program. That permits certain steps in a program to be repeated. Without loops, programs cannot perform certain steps over and over or again and again, and often without knowing exactly the number of times to repeat. In real life, we also rely on loops, because I just mentioned a few. Okay. So this is the simple logic of eating. Okay. And let's just say that someone is paying you to go to a buffet, and you can eat all you want. That is cool, right? I mean, especially if it's all you can eat, sushi, and the sushi is fresh. You don't want to eat fresh sushi that's not fresh. That would not be good. Okay, so the logic of eating is repetitive, because you just take a bite after another bite after another bite until you're done, until you're full. Of course, when you're at a buffet place and you are paying for yourself, then some people will say, "Oh, this is not enough to get out of the loop. I have to be close to burst, to get out of this loop, right? To get my money's worth." And that's why, in Rome they had vomitoriums. Vomitoriums.
When you go to vomit?
Yeah. So you empty out, then you can eat again. You can eat more stuff from the lead pots again. Yes, you can take more lead. You can eat some more, watch more people getting slaughtered in the Colosseum, and then go vomit some more, and then watch some more, eat some more. Yeah.
Hardcore there.
But they're models.
Yeah, and we wonder why the Roman Empire fell. All right, so what this is this is a text representation of a loop. Okay, the key words are repeat and until. Okay, when you see repeat until, that tells you that this is some kind of a loop. Whatever you put inside repeat and until is the action that you are repeating. That's the repetitive action. So in this case, the potentially repetitive action is taking another bite. So you keep taking a bite, taking another bite, and so on. One is full is the condition. It's also called the exit condition in this case, because when the condition is true, you get out of the loop. That's why it's also called an exit condition. And we have some explanations down here, about each line, which I'm not going to repeat. And this is a trace of that algorithm. The important part is this time around, that person is not hungry anymore, and the condition is true, and then we can exit the condition, and we're all done. If you want a picture or a pictorial representation of this is how I can draw the picture of a loop. Now, when you look at a picture like this, it is important to understand that the paths are all directional. Okay? It is not bidirectional, they're only unidirectional. So that means we can only come in through here. And when you look at this branch here, this is not a real branch. It is actually a merge, because this path here can only go in this direction. This path can only go in this direction. So this junction is actually a joint junction and not a split junction. It's not a branch out. They will merge into a single path, and then you take a bite. After you take a bite, you get out in a single way. But at some point, you do have a true branch here, because you can continue with this path, or you can continue on this path. Whenever you have a split or a branch, you have to look for the question. Because in order to decide which way to go, you have to answer a question. The question will answer with an answer of true or false. If the answer is true, in this case, you get out of the loop. If the answer is false, in this case, you go back and then you take another bite. Are there any questions about the picture that is representing the text version of the same code in the previous slide? It's okay? Okay. Well, let's go ahead and trace this. Let's figure out, we have only about, that clock is, a little bit behind. We have about 1 minute left. So let's see if we can do one trace, one last trace. X gets x plus 1 until x equals 5. Comments, line number, and also x. The precondition is, well, I can do this really quick. Let's say x started with a value of 3. That would make it faster. Right? And we start with line 2. Line 1, repeat, is just a marker line. There's nothing to do, so I don't even track it. Line 2 is incrementing x. X goes from 3 to 4. Then we go to line 3. Line 3 evaluates the condition. X equals 5 is false. And according to the logic, we have to go back to line 2. This is the loop. This is the important part. We are going back to a previous line. We add 1 to x again. X becomes 5. We go back to line 3. X equals 5 is true this time. And we get out of the loop, and it's post. And I got 5 seconds to spare. Yes?
Where did you start with 6? Where did you start with 6 instead of 3?
That's a very good question. So the brain teaser of the day, very good. Brain teaser of the day is, what if x starts with a value of 5? Let's not do 6. Let's say that x starts with a value of 5. What is going to happen with your trace? That's your brain teaser. That's your brain teaser. So give me the answer on Tuesday, or at least try to think about it on Tuesday.
It'll go forever.
Yep, that's what it would do.